Hey everyone, this video will show the solutions to the matrices review and test prep worksheet that we're currently working on to prepare for our test. You can go through those problems that you actually understand. If there's anything that you don't understand, you can scan through to those problems. You can just skip through the video to the right spot to figure this stuff out. But we're going to go through this step by step, each one. So if you already are familiar with something, it probably doesn't make a whole lot of sense to waste your time watching the solution to these problems. So let's start right at the beginning with number one. And we're asked to add or subtract these matrices. The first thing we need to know is that matrices need to have the same dimensions in order to add or subtract them. And we do each element piece by piece. So for number one here, we're going to add 0, or actually we're going to subtract -6 from 0. So our first element becomes 0 minus -6 is equal to 6. Our second element will be 2 minus -6, which is equal to 8. Our third element will be 2 minus -1, which is equal to 3. And our last element is going to be -1 minus 1, which is equal to -2. And we just wrap all that up into one final matrix, and this becomes 6, 3, 8, -2. We do the same thing with number 2. We're just adding in this case. So we'll go through piece by piece again. We take -1 and -2, we add those together. We get -1 plus -2 is equal to -3. Our second element is going to be 6 plus 3 will equal to 9. Our third element will be equal to 5 plus 4 is equal to 9. And our last element is -6 plus 5. And when we combine those, -6 plus 5 is equal to -1. So this simplifies to -3, 9, 9, and 1. And looks so far so good. Those answers agree with the answer sheet at the back of this packet. Once again, one more different configuration, but the same idea. So we're going to subtract again, and we do this element by element. So our first element is going to be 6 minus -3. Which is equal to 9. Our second element will be 6 minus 5, which is equal to 1. Our third element is -5 minus 2, which is equal to -7. And we're going to work on our second row. We have 5 minus -3, which is equal to 8. And let's see, we have 3 minus -6, which is going to be equal to 9. And then finally we have -3 minus 3, which is equal to -6. And 9, 8, 1, 9, -7, -6. Okay, that all looks correct. So this becomes 9, 8, 1, 9, -7, -6. Okay, For this next group, it looks like we are going to be scaling matrices. So all we're doing here is we are taking the value out front, that number 4, that's -3, and we're multiplying it by each value or by each element value inside the matrix. So we take -3 times 0 is going to be 0. -3 times -6 is going to be +18. -3 times -2 will be equal to +6. -3 times -2 is going to, -3 times +2 for the second row is going to be -6. -3 times 1 is going to be -3. And -3 times 5 is going to be -15. And I'll check those as I go. 0 minus 6, 18 minus 3, 6 minus 15. And that looks correct. Same thing with number 5. This shouldn't be too bad. We multiply 2 by -6 to get -12. 2 times 0 is going to be 0. 2 times 5 will be equal to 10. And 2 times 3 is equal to 6. And we'll check those. -12, 0, 10, 6. Okay, that works. Let's slide down to our next one. We've got more of these. They're just different configurations. So we're scaling this again. We're going to multiply 2, the scaling value out front, by each value inside of the matrix. So this becomes 2 times 1 is 2. 2 times 1 is 2 again. 2 times -6 is -12. And 2 times -4 is -8. For this next group, we have to do some addition and multiplication. And when we multiply matrices, we use the row and the column of each element. So if I start out with looking for the element on the top left, that's going to be this position. So that tells me that I need to multiply this row by this column. In fact, if we look at this from a multiplication point of view, we have a 3 by 2 matrix on the left. And if we're going to multiply that by a 2 by 2 matrix on the right, we know that our inner dimensions have to agree, and they do. And that's going to produce a matrix with dimensions the same as the outer. So we're going to actually have a 3 by 2 matrix when we're done with this. And we may as well just fill that in right now. And if we have a 3 by 2 matrix, we are going to have our first spot is going to be there. In fact, let's just do this piece by piece. So in order to get this particular spot here that's in yellow, the first one, we are going to use our first row because that corresponds to the row here. And we are going to use our first column because that corresponds to the column of that particular entry. But 0 and what we wind up doing here is 0. This is going to be our row, and this is our column. I multiply those values, but 0 times 0 is 0, and 0 times 2 is also 0, and we add those together and we get 0. Now we're going to look for our second element, and that still corresponds to our first row. So we're going to use that row, but now this corresponds to our second column. So we're going to use our second column, and we're going to multiply those out. And what we get is 0. Oops, let's take this piece by piece. 0 times 2 plus 0 times 2. But once again, both of those are 0 and 0, and when we add those together, we get 0. Let's take a look at our next element, which is going to be in this particular position. So once again, we use the row corresponding to that position, and we use the column corresponding to that. And now this is no longer going to be a complete 0 answer, but we multiply minus 4 times 0, but that's equal to 0, and we add to that 4 times minus 2, and this is equal to minus 8. And I'll drop that into there. When we sum those things together, this becomes minus 8. We're going to look at our next element, and let's get rid of our scratch work here. Our next element is going to be in this position, and this is in our second row, so we are going to use the values from our second row here, and it's in our second column, so we're going to use the values from our second column, and we're just going to multiply those piece by piece. So the first one comes into minus 4 times 2 is equal to minus 8. And then our second element is going to be 4 times 2, which is equal to 8. And when we add those two things together, it looks like we're going to get 0, and we drop that in there. Next element is in this position here. Let's get rid of our scratch work. Our next element is in our third row and our first column. So we are going to take our third row and our first column. We're going to multiply 4 by 0, and that's equal to 0. And we're going to add to that minus 2 times minus 2, which is equal to 4, and when we sum those together, we get 4. So it looks like this particular position is going to have a 4 in it. And we're going to work on our last element, which is this one here, but that is in our third row in our second column. So we are going to use our third row with our second column, and we're going to multiply 4 by 2, which is equal to 8. And then our second value is going to be minus 2 times 2, which is equal to minus 4. And when we sum those values together, we get a positive 4. And it looks like we are going to get a 4 in this position here. That's kind of the basics of multiplication. We just always do the same thing. So I'm going to get rid of the scratch work. And we'll slide down to the next problem. Okay. Once again, we can figure out what our matrices, what our dimensions are first. We have a 3 by 2 times a 2 by 2, and our inner dimensions agree, so we can actually perform the multiplication, and our outer dimensions tell us what our matrix is going to be. It's going to be a 3 by 2, so I will just drop that in there right now. 3 by 2, and I'll fill in some gaps here as we go. So our first position that we're looking to figure out is in the first row and the first column. I'm going to take my first row and my first column, and I'm going to combine those. So this becomes minus 5 times 3 is equal to minus 15. And our second element is going to be 6 times minus 1. But that's equal to minus 6. And when we sum those together, we get minus 21, I hope. And that's correct. So this first value becomes minus 21. We'll get rid of the scratch work. And we will look at our next element. Our next element is going to be up here. It doesn't matter which order you do these in, it all becomes the same. So this is in our first row, second column. So I'm going to use my first row and my second column. I'm going to multiply minus 5 by minus 1. And this is equal to 5. And I'm going to multiply 6 by 0. But 6 times 0 is 0. And when I sum those together, I get 5. And so I'm going to drop a 5 in there. We'll check these as we go. Yep, that value is okay. We're going to work on our next element, which is here. This is in our second row, first column. So I use my second row and my first column. And I'm going to multiply the individual values there. So I get minus 1 times 3 is equal to minus 3. And I multiply minus 5 times minus 1, which is equal to positive 5. And when I add those two together, I get 2. I'm going to drop that in there, and I'm going to check my answer, and that is correct according to the answer sheet. We'll work on our next value, which is going to be sitting here. This is in our second row in our second column. So I use my second row and my second column. And now I'm going to multiply the individual values. Minus 1, which is equal to 1. And I'm going to take minus 5 and 0, but minus 5 times 0 is going to be 0, and when I sum those together, I get 1. So 1 becomes the value that sits there. Next element, and get rid of this stuff. Our next element is in our third row, first column. So I am going to use my third row and my first column. I'm going to multiply those values. Multiply 3 by 3. I get 3 times 3 is equal to 9. And my second value, minus 4 times minus 1. But minus 4 times minus 1 is going to be 4. And when I sum those two together, I get, looks like 13. Let's check that answer, and that is correct. Get rid of this. And we're going to look for our last value in here, and this becomes this element down here. This is in our third row, second column. So I use my third row, my second column. I'm going to multiply the individual values. 3 times minus 1 is equal to minus 3. And minus 4 times 0, 0 is always an easy one. Minus 4 times 0 is equal to 0. When I sum those up, I get minus 3. So this becomes minus 3. And that checks. So everything is good up through number 8 at this point. We'll take a look at number 9. We're going to do exactly the same thing that we've done with these other ones. We have a 3 by 2 multiplying a 2 by 2. The inner dimensions agree. That's good. The outer dimensions become the dimensions of our new matrix. So I know I'm going to have a 3 by 2 matrix. So I'm just going to plop that there and take each value as we go. Value number 1 is in the first row, first column. First row, first column. Multiply those together. Minus 5 times minus 4 is going to be equal to 20. And minus 4 times minus 4, minus 4 times minus 4 is equal to 16. When I sum those two together, I get 36. We'll get rid of all of this. We'll work on our second element, which is row 1, column 2. So I will use row 1 and column 2. I'm going to multiply minus 5 times minus 1 to get 5. And now I'm going to multiply minus 4 times 6. Minus 4 times 6 is going to be minus 24. And when I sum those together, it looks like I'm going to get minus 19. Let's check that there, and that agrees. So minus 19 is good. We will move on to our next element, which is in the second row, first column. So we will take our second row and our first column. We're going to multiply 3 by minus 4, which is minus 12. And we're going to multiply 6 by minus 4. And I get minus 24. And when I add those together, it looks like I get minus 36 again. Well, not again, but minus 36. And that checks out. So we'll continue on. Next element. Second row, second column. So I'm going to multiply my second row by my second column. My first value becomes 3 times minus 1. 3 times minus 1 is equal to minus 3. My second multiplication is going to be 6 times 6. But 6, oops, no negative sign there. 6 times 6 is going to be 36, and when I sum those together, I get 33. And hopefully that is correct. It is. Nice. We'll take a look at the next element, which is in the third row, first column. So I use the third row, first column. I'm going to multiply minus 6 by minus 4. Minus 6 by minus 4 is going to be equal to positive 24. And 4 times minus 4 is going to be equal to minus 16. And it looks like that sums up to 8. We'll check that out, and that agrees, so that's good. Going to work on the last element for this particular matrix, which is in this position here, and that is in our third row, second column. So we're going to use third row, second column. We're going to multiply minus 6 by minus 1 to get positive 6, and we will multiply 4 by 6 to get 24, and when we sum those up, we get 30, and hopefully that agrees, and it looks like it does. So we get a 30 in there. And that takes care of number 9. Get rid of this stuff in here. Okay, that's good. We'll slide down to our next problem. We're evaluating determinants now, and these aren't too bad because these are 2 by 2s. So as with all of these things, slide back over here. When we're evaluating determinants, we take our first diagonal, we multiply those together, and then we subtract our opposite diagonal after those are multiplied together. So I am going to multiply -5 times -2, and from that I am going to subtract 0 times 0, but this is going to be +10, so this determinant is equal to 10. We do the same thing with number 11. We're going to multiply the first diagonal, and then we're going to subtract from that product the product of the other diagonal. So we have 0 times 4 minus 1 times -1, but that becomes 0 plus 1. Is equal to 1, so this becomes 1. Slide down to our next one. Now we're finding the inverse matrix. So we have our big process that we do here. The first thing we do is find our determinant. So let me slide down so that actually shows up. Okay, so the determinant for this one is the same as we just calculated before, right? We're going to multiply the diagonal, and we're going to subtract from that product whatever we get on the other diagonal. So the determinant will be equal to -2 times 0 minus -5 times -7. So it looks like this is going to be 0 minus 35 is going to be equal to -35. I'm going to get rid of this stuff over here because now we're going to go through the messy process that comes in with the production of the matrices. And the first thing that we calculate is the minor. We move on to the cofactor, then the adjugate, and then finally the inverse. So if we're going to talk about our minor, we know that that's going to be a 4 by 4. Sorry, not a 4 by 4, a 2 by 2. And I'm going to indicate that with an M. And I'm going to work on each one individually. So my first spot that I need is in my first row, first column. So what I'm going to do is eliminate first row, first column. The value that goes in the minor matrix is whatever is left. So this means that 0 is here. I'll clean this up. I'm going to work on my second element, which is going to be up here. So that is in my first row. I eliminate my first row. It's in my second column. I eliminate my second column. Whatever is left is the value that goes in there. So we have -7. I'm going to work on the element here, which is in our second row, first column. So I'm going to eliminate my second row and first column, and the value that is there is whatever is left, which is -5. And finally, I am going to work on my last element in my minor, which is down here, and this is in the second row, second column. So I am going to eliminate my second row, eliminate my second column, and the value that is left over goes in here. So the minor matrix is now complete. That's actually the big work in all of this. We're going to move on to calculate our cofactor. And our cofactor follows this idea of changing the sign of the elements in the minor matrix selectively. And we do that with this sort of a pattern. And we change those values, we change the sign of the minor elements where we find negative signs in this in this additional just like sign type of matrix. And when we do that, we see that we're going to have to change this -7, and we're going to have to change this -5. Those are the positions that agree with the sign values that we have to change. So for my cofactor matrix, I know that this is going to be 2 by 2. So I have a 0 up here. My -7, I have to change that, so that's going to become a +7. My -5, I have to change that, so that's going to become a +5. And the -2, I leave alone. The cofactor matrix is now done. Now we need to find the adjugate matrix. And the adjugate matrix is the transpose of the cofactor matrix. So I will call that this here, this A. And when we find the transpose, all we're really doing is swapping columns and rows, or rows and columns. So I'm going to take my column and I'm going to turn it into a row. My first column becomes my first row. So moving down 0 to 5, I'm going to turn that into a row. So this becomes 0 and then 5. The direction moves down and then from left to right. For my second row, I need to look at the second column. So I have 7 and -2. So I'm going to take 7 -2, and that becomes the adjugate matrix. Now we have to take those values, and to get the inverse, we're going to divide the adjugate or scale the adjugate by 1 over the determinant, which we had just calculated a little while ago. So the inverse to this matrix is going to be 1 over -35, which is the same thing as -1 over 35. And then we're just going to drop in that adjugate matrix, which is going to be 0, 5, 7, and -2. That's the inverse for this particular solution. We're going to move on to number 13, and we're going to do the same thing. This is the same process. They're asking us to find the inverse of this matrix. And so the first thing we need to find is going to be the determinant. And to find the determinant, we are going to find the product of the diagonal. And from that, we're going to subtract the product of the other diagonal. So I have minus, and I'll label that as I go, sorry. The determinant will be equal to 0, -1, -7 times 0. But this whole thing is just 0. This becomes an easy one. And this is why we do the determinant first. The determinant is 0. I can't divide by 0, or I can't multiply by 1 over 0. So the inverse does not exist. You can just save yourself quite a bit of work and some time by getting rid of that one first. Okay, so now we're actually going to apply this. We're going to use the inverse matrix to solve for these things. I'll label this as we go. This is going to be kind of messy because there's probably not enough room to get through all of this. So for number 14, let's see, how much room do I have? Not much. I'm going to label these and we'll just go through it. So this, I'm going to call this, A times X, and we're solving for X. B, and this is what we're looking to find. We're looking to figure out what the matrix X is. And in order to do that, we have A times X is equal to B in matrix notation, but we know that if we pre-multiply both sides by A inverse, that A inverse times A is equal to the identity matrix. And the identity matrix just keeps X the way it is, but this tells us that X can be found by multiplying the inverse of A by B. And that's the process that we're going to go through here. I'm going to use the short technique with this, with calculating a minor. We'll calculate the determinant first though, because we still have to do that. So our determinant is going to be equal to one diagonal, the product of one diagonal element minus the other. So this becomes 5 times minus 1 minus 1 times 4. And this is equal to minus 5 minus 4 is equal to 9, or sorry, minus 9. That negative sign is sort of important. Let's make sure that I'm doing this correctly. Okay. We'll get rid of all of this stuff in here. And now we're going to go through and we're going to find the minor of A. Remember, we're working with the matrix that's associated with our unknown matrix. That's what we're looking to get rid of here. So to find the minor, I'm going to do the cheap trick for a 2x2, and I'm just going to swap the corners. And that means that I'm going to swap this element and this element. So this first one becomes minus 1 and 5. And then I'm going to swap my other two corners. So I'm going to swap this element, this one up here with the one down in the bottom over here. And when I actually do that, I get 4 and 1. We'll clean this up in here. Now we need to find the cofactor matrix. But the cofactor matrix, we use our sign, which is going to be plus, minus, minus, plus. We identify the elements in the minor matrix that need their sign changed, and we know that that occurs where these signs are negative. So we're going to adjust this value and this value, and the cofactor becomes minus 1 stays the same, 4 changes to minus 4, minus 1, 1 changes to minus 1, and 5 remains the same. We are going to do our adjugate matrix, and I will call that ADJ here. And once again, we are going to swap columns with rows. So I am going to take my first column, and I'm going to make that my first row. So this is going to be minus 1 and minus 1. I'm going to take my second column, and I'm going to make it my second row. So this becomes minus 4 and 5. Almost done here now. I have my inverse. I know that my determinant is minus 9. I'll slide down a little bit. So my inverse matrix is going to be minus 1 over 9 times minus 1, minus 4, minus 1, and 5. And now finally to get x, we know that x is equal to A inverse times B, but this is A inverse here. So now we're just going to multiply A inverse times B to get x. Minus 1/9 times minus 1, minus 4, minus 1, and 5. I need to slide back up a bit to get B. And it looks like that is going, hopefully that's not going to get, it's overridden. I'm going to have to copy this down from a different source. Actually, you know what? I can get rid of this, and we're going to multiply this by minus 21, 3, 18, and 27. Hopefully I got a little bit of room here. Not much. I'll do the actual workout on the side here, and then we'll leave this done at the bottom. And I'm going to put another layer on this so that I can do this. So we do the same thing with the multiplication, right? We want to find, we're going to leave a minus 1/9 out front for now. And we're going to try to fill in some values over here. So the first thing I want to work with is going to be, actually we'll fill this in, we're going to work with this slot here. So that means I need to take my first row, my first column, and I get -1 times -21, and I add to that -1 times 3, and it looks like that is going to be, is that correct? Hold on a second. Okay, so this is going to be 21 minus 3, which looks like 18. And I'll put the 18 in blue here down below. Actually, we'll just put that there, 18. And now I'm going to work with my second element, and we'll place that below. I'm just going to do this in a different order this time around. So if I want to work with this particular element that is in the second row, first column, I am going to multiply second row by first column, and we get -4 times -21 plus 5 times 3, and we've got to do some math here. It looks like that is going to be, no calculator handy, so this is going to be 84. 84 plus 15, it looks like it's going to be 99. We will get rid of this little side thing over here. Oop. We're going to work with another element, and we're going to place this one up here. So this is going to be our first row, second column. So we work with first row, second column. And when I multiply that out, this becomes -1 times 18 plus -1 times 27. And 27 and 18 are, should really have a calculator for this. Looks like that's going to be 45. And it's going to be a negative value, so that's going to be -45. And our last value for this, which is kind of painful, we are going to work with second row, second column, so we will multiply second row by second column and drop those values in. This becomes -4 times 18 plus, looks like 5 times 27, and I should really use a calculator for that. It looks like that's going to be -72, and 5 times 7, 27, 5, 35, looks like 135. So we're going 135 and -72 is going to be 3. It looks like that's 6, which is nice. So this is going to be 63. And the key thing about these is they're all rigged to a certain degree. When you see that -1/9 out front, everything that's in here turns out to be a multiple of 9. So when you divide this all out, you actually wind up getting x is equal to 18 divided by 9 is going to be -2, and 99 divided by 9 is going to be 11, but this is going to be negative also. Don't forget that negative sign out in front. And our element up on the top here, the top right, first row, second column, is going to be -45 divided by 1/9, so that's going to be +5. And then 63 divided by 9 is going to be 7, and that's going to be negative. And hopefully that agrees with what we've got, -2, -5, -11, and -7. So that checks out. That is, that solves for x for this particular one. And I don't really have a whole lot of room left to do 15. Let's see what else we got on this thing. And we've got some bonus problems here. We would solve that in the same way. No, I guess we have some other ones. These are relatively simple ones, though, here for 16 and 17. If we're looking to find y for some particular value, we can just add and subtract. It looks like y is added to this thing. So if we add another matrix to this side that is going to be, actually we're going to subtract what we've got there, -1, 5, 10, and 9. So this looks like we're going to add to both sides. We're going to add a 1, -5, -10, and -9. And when we add that to the other side, we get 1, -5, -10, and -9. We add those things together, and each of those elements, this is just like adding another matrix that's the same dimensions. So we get 8, 8, and looks like this is going to be 21 minus 10 is going to be 11, and -8. And hopefully that came out correctly. 8, 8, 11, -8. So when we add those two together, this is what we wind up getting. The same thing is true for 17, right? This is just, we see that 5 that's out in front here. This isn't a matrix, right? That's just a value. So we can consider that as a scalar, right? And we can divide that out directly. So if I just divide this by 5, it's the same thing as multiplying -1/5 times -1/5. And this means that b is going to be equal to -1/5 times -15, -25, and -15. And once again, these are pretty rigged. So they all divide out evenly by 5, and they all turn into positive values. So b is going to be equal to 3, 5, and 3. And I'll check that, and it looks like that is correct. These are some bonus problems. We may as well go through them anyways. So we do the same thing that we do before. We just have some letters that are associated with this now instead of just pure numbers. So we can, if we see that we have a 2 by 2 multiplied by a 2 by 2, we know that we're going to get another 2 by 2. And let's just write that in there to begin with. So we'll drop this down here. We're going to go through the same process that we did before. We're looking, and I should maybe make this a little bigger. We'll leave that open-ended for now. So I'm going to multiply, I'm looking for this particular slot up here. That's first row, first column. I multiply first row by first column. We get 6n times 1, 6n times 1, but that's equal to 6n. And we get 0 times -4, which is equal to 0. But when we sum those up, we get 6n. So in our first slot here, we get 6n. We're going to take a look at our next value, and I'll place that below it here. And this is going to be our second row, first column. So in order to get that, I'm going to take my second row and my first column, and I do the same thing. I multiply n squared by 1, but that's equal to n squared. And I have -m times -4, but that's equal to 4m. So this becomes n squared plus 4m in this slot. We do the same thing over and over and over again. We have our first row, second column. We multiply our first row by our second column, and I'm going to get rid of this scratch work down here. So I have 6n times minus 5m, but that's equal to minus 30nm, and then my second value is 0 times 3, and when I add those together, that's 0. This becomes minus 30nm. So this is minus 30mn. And our last value for all of this is in our second row, second column. So we take our second row, second column, multiply that out. Now we have n squared times minus 5m, and that's equal to minus 5n squared m. And we take our second value there, and we have minus m times 3 is equal to minus 3m. When we add those together, we get minus 5n squared m minus 3m. And I'll check to see that that's correct, and it looks like it is. So this becomes minus 5n squared m minus 3m. And that is the simplification of this particular matrix. It's the same thing, we just have variables instead of numbers. That's a bonus problem. Not really necessary to know, but if it'll add to your score. So we have a 3x3 determinant, and you can do this any way you want. You can either add the rows on. I've always done it using minors and cofactors. So that's the way I'm going to break this out to solve this. I'll cross these things out as I go just so that you can see where my numbers are coming from. I deal with each value across the top. So my first value is going to be this 3. I'm going to put that down here. And then when I get rid of the column in the row, I'm left with a determinant that looks like this. Minus 3, minus 3, and 3, minus 4. I'm just going to set the whole thing up first. My second value is going to be this minus 4, but I have to subtract this, minus 4. I eliminate the column, I eliminate the row, and I'm left with a determinant of 4, minus 4, and minus 2, and 3. And I sum for the last one. So I'm working with my 1 value now. So I'm going to put that down here. And I eliminate the column, I eliminate the row, and I have to multiply that by the determinant that's left, which is 4, minus 3, minus 2, minus 3. And when I do these out individually, I'm going to use the same thing for each one of these. So the first one becomes 3 times minus 3 times minus 4 is going to be 12, minus 9, which is going to be plus 9. I get the minus 4 turns into a plus 4 times minus 16 minus 6, which is going to be plus 6. And then the last one, I just get 1 times minus 12 minus 6. And hopefully this all works out okay. It looks like this is going to be 3 times 21, which is going to be 63, plus 4 times minus 10, which is going to be minus 40. And finally, it looks like plus 1 times minus 18, which is going to be minus 18. And when I add all that up, it looks like minus 48 and 63 is going to be it looks like 15. And let's see if that checks out. Minus 19. And no, it does not check out. Let's see, 40. Oh, that's because, sorry. Minus 48 and 63 this actually turns out to be, minus 58. And the difference between minus 58 and 63 is going to be 5. So this becomes 5. Sorry about that. And hopefully, the 3 by 3 inverse, that's going to be kind of painful. I don't think we have time. I'm not going to have time to put that in this video here because we have a class coming up. So I'm going to end this for here. I will actually write out a solution for 20 so that you can take a look at how that goes. But other than that, hopefully this helps out.